Okay, so we're going to talk about section 1.1, which is called numbers. And this is lecture number 1. If you haven't already read the textbook section, which is in the course website, then go back and read section 1.1 first, and then come here. So we're going to talk about a couple things that are a little bit different than actually in the textbook, but along the same line. So the first thing we're going to talk about is notation. So we can write 4 times 3 in any of these ways. So usually the dot and just having a bracket and not even having any kind of multiplication symbol is reserved for using it with algebra. But we're going to introduce it here. These are all equal, and they're equal to 12. The other thing to notice is when you multiply, you can multiply 3 times 4 or 4 times 3 and get the same answer. And that works as well for addition. Okay, this is called the commutative property. So you can work either direction and you get the same answer. So subtraction doesn't work the same way. Oops. So if we do 2 minus 5, we get negative 3, and we do 5 minus 2, we get negative 3. So this is not commutative. And neither is division. So if we did 6 divided by 2, that's equal to 3, and 2 divided by 6 is 2 divided by 6, which is 1/3. So these are not commutative either, and notice the difference between them. Okay, so 3 and 1/3 are called reciprocals of each other. It's like you flip over the fraction, so the reciprocal. And here, these are the same number but opposite sign, so they have the opposite sign. When you subtract one way, or you switch it around and subtract the other way, you get a different sign. So now, if we talk about multiplying or adding numbers, more than one number at a time. So, for example, if we had something like this, 2 times 7 times 3 times 5, and we wanted to multiply. Well, order of operations says to start at the left and multiply each number. So here we would multiply, this would be 14, and then 14 times 3, you would have to figure that out, and then whatever that answer is times it by 5. 14 times 3, I'm already stuck here doing it in my head, but what if we changed the order of these numbers? Now, because multiplication is commutative, we can actually multiply these in any order that we want. And now 10 times 21 is 210, and that was much easier. So that's called the commutative property. And similarly, like if you were playing a board game, say Yahtzee or something, and you had some numbers to add together. Okay, so we had these 4 numbers to add together. We could just list them in a list and then add in the normal way. That's called the addition algorithm. Or we could regroup these numbers. If I put the 17 with the 23, because this one ends in 7 and that ends with 3, 3 and 7 equals 10, this is easier to add together. The other numbers, 21 and 19, sort of the same thing happens. This is a 9 and a 1, which is 10. So here, if we add this, we will get a 10. So it would be, if we add that 3 to the 17, we would get 20, and a 20 here, so that'll be 40. And here we also have 40. 40 and 40 is 80. And so it's a little bit easier than just multiplying from left to right. So order of operations, although it's a starting point to teach people how to proceed with a complicated expression, it doesn't always need to be followed. So order of operations, whatever acronym you had. If you're French, you probably had a P here instead, for parentheses instead of brackets. But this is brackets, exponents. These two go together, and it is division and multiplication, and it can be in any order. And then here we have addition and subtraction, and they can be in any order. And so what this is saying to do is to do your brackets first, then your exponents, and then you do your division and multiplication from left to right, and then your addition and subtraction from left to right. So let's give an example. Okay, so here we go. If we did this using order of operations, so actually let me just rewrite the question here on the new page, so we have room. Okay, so let's use order of operations to solve this. So I'm going to circle what we're going to do first. So any brackets, we're going to do brackets first. So that would be here. So we're going to put an equal sign, and we're going to do this bracket first, which will give us 9, and then you rewrite everything else exactly as it is. And then our next step is exponents. So that would be right here. So 9 times 4 minus 3 squared is 9. And then you do any multiplication. So here is one multiplication, and here is another. I have one with a dot and one with the times. You wouldn't normally see that in the same question, but 9 times 4 is 36. Rewrite this one. 9 times 2 is 18. And then order of operations says now we only have plus and minus, and in this order, from left to right, we do 36 minus 9, which is 27, plus 18. And then 27 plus 18. I'm doing this in my head, so I'm actually breaking it up like this. And I'm saying 8 and 7 is 15. So 20 and 10 is 30 plus 15. 30 plus 15 is 45. And the other way, of course, would be to take these and add down 15, carry the 1, and get 45. Okay, now I'm going to do the same question, but we're going to do it shorter and not following order of operations exactly as they're stated. So more of a practical application, and we're a little more experienced, so we can do this. So we're going to write the exact same question down. Okay. So what you're going to look at whenever you look at an expression is the number of terms. So a term is separated by a plus or minus sign. Okay, so we've got a plus or minus sign here and here. So in this particular question, we've got 3 terms. Here's term 1, here's term 2, and here's term 3. So 3 terms. Now, just carrying that plus and minus sign down, we can actually evaluate each of these 3 terms and put them in where they are. So term 1, 4 plus 5 is 9. And 9 times 4 is 36. So we could actually write 36 here. 3 squared is 9. And 9 times 2 is 18. Put an equals at the beginning. So 36 minus 9 plus 18. So up above, instead of doing just the bracket first, then in the next line doing just the exponent, then in the next line doing the multiplications, and then finally adding them together, we can jump right to evaluating each term separately, separated by a plus or minus. I know there's a plus sign here, but this is not a term because this times 4 is holding it all together as one number. So then you could evaluate this, and in fact you don't need to do it in that order. We could switch the order around. The important thing here is that the 9 is being subtracted. So we could say this is 36 plus 18 minus 9. You could do it in that order. Not that 36 plus 18 is any better, but I do like 18 minus 9 is 9, and then 36 plus 9 is 45. So you could do it really in any order. The important thing to remember is that the 9 is negative. Okay, so another example. Say we wanted to do 5 times 18. So just multiplying numbers. You can use the standard algorithm, which is like this. 5 times 8 is 40. 5 times 1 is 5 plus 4 is 9. So the answer is 90. But another way to do this is to break it down. So this is 10 times 8, and then we would actually use, 10 plus 8. 18 is 10 plus 8. And then we would use FOIL, or expand this, 5 into the bracket. So we would have 5 times 10 plus 5 times 8. So this would be 50 plus 40, which is 90. And this is a useful way to calculate some questions, as you can actually do this in your head. You can think of this as a 10, the 18. The 1 from the 18 is a 10, so 5 times 10 is 50. And then 5 times 8 is 40, so you have a 50 and a 40, which is 90. You get your answer. So we'll just try another one of those. So this would be 7 times 20 plus 4. So that would be 7 times 20 plus 7 times 4. Now 7 times 20 is 7 times 2 is 14 with a 0 on the end. 7 times 4 is 28. So this is 168. Okay, so that's the idea. Okay, so questions can be written in all sorts of ways. Now, let's go and look at some negative numbers. So, for example, if I had negative 3 squared, that appeared in another question. Well, this is saying the same as saying negative 1 times 3 squared. That negative is not really attached to the number 3. It's like a negative in front of a 3 squared. So this is negative 1 times 9, which is negative 9. Now the opposite is if we had negative 3 squared. Well, now the negative 3 is what squared? So that's like a negative 3 times a negative 3, which is positive 9. Okay, so be careful of whether the negative is outside of the bracket or it's inside the bracket. Okay, so we're going to put some questions together. Let's say that the instructions say solve or simplify. Okay, so number 1. Here we go. So we're looking at just 2 terms here. The 3 is a term by itself, and this whole thing, because that bracket's holding it together, is a term. Now the only reason I have a square bracket is so to differentiate the brackets, just so that you can see that these go together and these ones go together. But there's no other meaning behind a square bracket. So we're going to write this out, and we'll do this first, which is 5 plus 1 is 6. 6 minus 2 is 4, and the answer is 7. So what we're looking for is our question written out, equal signs down, and then your work. And so we want equal signs always going down the page. Now, on an assignment or anything, you can do this. You can always put your other question off to the side. I would just separate it so it doesn't look confusing. Okay, so say we had 7 plus 3 plus a minus 4. Okay, so again, it's just 2 terms. It's a 7, and then this whole bracket is held together, so that's a second term. I'm going to write an equal sign. We'll rewrite the 7 plus 3. A plus and a minus together is a minus 4. So then we're going to say 7 plus, and 3 minus 4 is negative 1. So we have 7, a plus and minus together again is a negative 1. So 7 minus 1 is 6. So anytime you see those plus and minuses together, or two signs together, change it right away. And then it's going to be easier to figure out. Number 3. Okay, so here we've got how many terms? So you're going to look through this, and you're looking for plus and minus signs. So there's one here, minus, and a plus sign here. So there's 3 terms. 1, 2, 3. There's our 3 terms. So we're going to evaluate our 3 terms separately. So this is 8 inside the bracket. 10 divided by 5 is 2. 16 is already 16. Minus 1 cubed is minus 1 times minus 1 times minus 1. So this is positive 1 times minus 1, which is negative 1. 3 negatives is a negative. Eight times 2 is 16, minus 16, minus 1. You notice there's a positive 16 and a negative 16, so they would cancel out, and we would just have negative 1 left. Four. Now we're just going to do this one a little bit different. So here, what I'm going to show you with this one, there are 3 terms. Okay, because you're looking at between the plus and minus. So there's 3 terms here. But what you might notice in all 3 of these terms is that they all have a negative 4. So we can actually factor out that negative 4. Just putting a big bracket so we can see the bracket. If we take the negative 4 out of negative 4 times 2, we're left with a 2. Take the negative 4 out here, we're left with a positive 7. And if we take the negative 4 out here, we're left with a negative 10. So this is negative 4. And then if we work out the inside of this. So again, they're all plus or minus. As long as you keep the 10 as being negative, then you can do these in any order. But 7 plus 2, or 2 plus 7 is 9, minus 10 is negative 1. Negative 4 times negative 1 is positive 4. Okay, we'll just do another example. Negative signs seem to be a problem. Let's do negative 2 cubed minus 2 squared plus a negative 1 squared minus a negative 1 cubed. Okay, so we've got some negative signs in here. So those of you that are prone to sort of silly mistakes, this is where it comes in. So you have to, like I said earlier, watch what is actually in the bracket. So here we've got a negative 3, or a negative 2 cubed. So negative 2 cubed is negative 2 times negative 2 times negative 2. Well, 3 negatives make a negative. 2 times 2 is 4, times another 2 is 8. So that's minus 8. Here, this is a negative in front of a 2 squared. So 2 squared is 4. So there's still a negative sign because it's only the 2 that's squared. Here we've got a negative 1 squared, which is negative 1 times negative 1, which is positive 1. And here a negative 1 cubed, which is negative 1. And then there's another negative sign there, which will make it a positive. Put an equal sign. Make sure you don't have any double signs. Negative and negative is a positive. And then here we've got minus 8 minus 4 is minus 12. And 1 plus 1 is 2, minus 12 plus 2 is minus 10. Okay, so we're going to stop there. What you're going to do is go back and do the homework questions or the practice questions for section 1.1, and then read section 1.2. So do the questions for section 1.1, and then read section 1.2, and then we'll be on to lecture 2, which is section 1.2.